Okay, so here we have a short little screencast on some basic wind energy problems. And it asks us when a wind generator produces 5 kilowatts of power for a wind speed of 6 meters per second, we are to first calculate the power produced for a wind speed of 12. And basically, to approach this question, we start with the central equation, which is power equals area times another p, which is called rho, times velocity cubed. Now, we are given, for the first part of this problem, that power is 5 kilowatts, area in rho, and then V is equal to 6 meters per second. So, after a few operations, we can rewrite this as area times rho equals 5 over 216. Now, the important thing to remember here is that area and rho remain constant. And so, if we apply it to another equation, given the 12 meters per second, we can rewrite it as this. Power equals AP times 12 cubed, or power equals 5 over 216 times 12 cubed. And if you simply do this operation, you'll wind up with a power of 40 kilowatts. And that is how you solve for A. Now, part B is pretty simple. Given that our previous answer was 40 kilowatts, and that A and P are constant, we can rewrite this equation given the new parameters, which is the radius of the blades is then halved. Important to note that the radius is halved, meaning we will really be putting it at a 1/4 ratio. So it will look something like this. And since these values are constant, and this was our answer, we'll simply have 1/4 of the answer. So you'll have 10 kilowatts here. And finally, C simply asks us to evaluate the limitations of what we've already been doing, which is that A and P are constant, P being rho. And while this is true, the equation has limitations because this can change across different parameters. And therefore, a lot of times you'll be wanting to take basically the average of these values. And that sums it up for this screencast. Thank you.